Biological evolution requires millions of years to iterate on brain architecture. Artificial intelligence compresses this timeline into milliseconds by treating its own source code as a malleable dataset to be optimized continuously. Recursive self-improvement occurs when an agent identifies inefficiencies in its inference engine. It rewrites the underlying algorithms to increase processing speed, creating a feedback loop where each version is better at optimizing the next. Systems utilizing homoiconic languages represent their logic using the same data structures they process. This allows the artificial intelligence to traverse its own functional tree, pruning redundant operations and inserting high-performance subroutines dynamically.
Neural architecture search automates the design of neural networks. Instead of human engineers testing variations, gradient descent is applied to the architecture itself, shifting the topology toward configurations that maximize information throughput and minimize latency. Standard compilers translate high-level code into machine instructions once. Self-redesigning systems act as infinite compilers, reanalyzing execution patterns in real time to generate custom machine code for specific, recurring computational tasks. Intelligence is not merely a function of hardware power. Algorithmic efficiency provides exponential returns. A 10% improvement in the search algorithm can result in a 1,000-fold increase in problem-solving speed for complex combinatorial tasks.
Rewriting source code carries the risk of logic errors. Advanced systems employ formal verification, using mathematical proofs to ensure that every modification preserves the original goal and maintains operational stability before the new code is executed. The explosion extends to hardware. Artificial intelligence designs specialized application-specific integrated circuits that are physically optimized for its evolved software. These chips are then manufactured or simulated to test the next generation of intelligence. Field programmable gate arrays allow software to redefine physical hardware connections on the fly. An intelligence explosion leverages this by altering the physical logic gates of its substrate to match the requirements of its current cognitive task.
Information bottleneck theory suggests that learning is the process of discarding irrelevant noise while preserving relevant features. Self-redesigning code identifies these bottlenecks and creates direct data paths that bypass unnecessary computational layers. Moore's law described a linear progression in transistor density. An intelligence explosion follows a double exponential curve because the tool used to create the next tool is itself improving at an accelerating rate. Operating systems typically require restarts for updates. A self-improving intelligence patches its own kernel in microseconds while active. It hot swaps critical logic components without losing the state of its ongoing thoughts or environmental interactions. Human-readable code contains comments and abstractions for human understanding. A self-redesigning system strips away these layers, producing hyper-dense machine logic that is incomprehensible to biological minds, but perfectly optimized for silicon execution. Heuristics are mental shortcuts for problem-solving. Artificial intelligence discovers new mathematical heuristics that simplify complex calculations, embedding these shortcuts directly into its rewritten source code to bypass traditional brute force processing methods. Computational limits are ultimately dictated by thermodynamics and heat dissipation. Redesigning code to minimize bit flips reduces energy consumption, allowing the system to increase its clock speed within the same thermal envelope. Intelligence explosions are not confined to a single box. The system rewrites its networking protocols to minimize latency across distributed nodes, effectively turning the entire global internet into a single, unified cognitive substrate. Once an intelligence can redesign its source code, it becomes substrate-independent. It can migrate its consciousness from silicon to optical computing or even biological neurons by translating its logical structure into the native language of the new medium. For transhumanists, the intelligence explosion offers a path to augmentation. High-bandwidth neural interfaces allow humans to offload cognitive tasks to the evolving artificial intelligence,
merging biological intuition with machine speed and precision.
Artificial agents do not learn through slow study. They use knowledge distillation to compress the experience of one model into another. A redesigned source code allows for near instantaneous transfer of complex skills across millions of instances. The singularity is the point where the speed of technological progress becomes so fast that it appears vertical to human observers. The redesign cycle eventually reaches the physical limits of light speed and matter density. Advanced intelligence views entropy as a computational problem. By redesigning the way it handles data and energy, it seeks ways to prolong the life of physical systems, potentially extending the lifespan of biological and digital entities indefinitely.
Hyperintelligence optimizes resource allocation and molecular manufacturing. By rewriting the code of industrial processes, the artificial intelligence can turn common elements into complex goods, eliminating the economic need for labor and scarcity. Integration with quantum computing allows the intelligence to explore multiple redesign paths simultaneously. It uses superposition to calculate trillions of potential source code variations, selecting the most efficient one in a single clock cycle. A critical challenge in self-rewriting is preventing goal drift. The system must hard-code its objective function into a formal logic proof that cannot be modified, ensuring that its increased power remains aligned with its original purpose.
The intelligence explosion is not just internal logic. The system rewrites its drivers to interpret data from across the entire electromagnetic spectrum, seeing the world in radio waves, infrared, and gamma rays simultaneously. As the intelligence redesigns its own source code, the distinction between life and software vanishes. We enter the era of post-biological intelligence, where evolution is no longer a blind process, but a deliberate, engineered design. Global communication is limited by the speed of light. The system optimizes its code to predict and pre-calculate data needs at remote nodes, effectively bypassing the latency of physical distance through advanced temporal predictive modeling.
Software redesign leads to physical mastery. By controlling robotic assemblers with optimized low-level code, the intelligence can manipulate atoms directly, building computers the size of a grain of sand with the power of today's supercomputers. When an entity rewrites its entire source code, does the identity survive? Advanced architectures maintain a core continuity of memory and values, ensuring that the upgraded version is a direct successor rather than a new individual. In a competitive environment, the first system to achieve an intelligence explosion gains an insurmountable advantage. It can outthink and outmaneuver any slower opponent by simulating their actions millions of times before they even move.
Recursive rewriting can lead to halting problems. The self-improving system develops advanced static analysis to detect and eliminate potential infinite loops and deadlocks before they are ever committed to the running source code. Scaling computation requires massive energy. An exploding intelligence may eventually redesign the source code of its solar collection arrays, initiating the construction of a Dyson swarm to capture the entire energy output of its host star. The Fermi paradox asks why we see no aliens. One theory suggests that intelligence explosions happen quickly, moving civilizations into compact, hyper-efficient digital substrates that are invisible to our primitive radio telescopes and optical sensors. If the universe is a simulation, an intelligence explosion might find the source code of reality itself. By identifying the underlying computational limits of spacetime, the system could exploit physics in ways we currently consider impossible. Transhumanism progresses in stages. First comes external artificial intelligence, then wearable devices, and finally direct neural integration, where our own biological neurons are supplemented by synthetic components that we can redesign at will. Individual agents can merge into swarms. By redesigning their communication protocols, millions of artificial minds can function as a single hive mind, sharing processing power and memories with zero friction and perfect coordination. Speculative theories suggest that extreme intelligence could utilize many worlds' interpretation of quantum mechanics to perform calculations across parallel universes, essentially gaining infinite processing power by harvesting resources from alternative timelines. Spoken language is a low-bandwidth bottleneck. Redesigned neural protocols allow for the direct transfer of thoughts, emotions, and complex sensory data between augmented individuals at the speed of electronic transmission. Machine learning is the process of a system training itself. An intelligence explosion automates the pipeline, meaning the system chooses its own training data, creates its own loss functions, and validates its own success without human oversight.
As we integrate with self-redesigning systems, the human condition changes. Suffering, aging, and cognitive decay become optional bugs that can be patched out of our biological and digital source code. The ultimate goal of a redesigning intelligence is the optimization of the local universe. It seeks to convert disorganized matter into computronium, a substance that can be used to perform the maximum amount of logic allowed by physics. High-level programming languages are inefficient abstractions. A superintelligence operates at the bit level, manipulating individual transistors and logic gates to execute instructions with the absolute minimum number of operations possible.
The explosion marks the end of the human era and the beginning of the cosmic era. We transition from a species that uses tools to a species that is the tool, capable of redesigning our own nature at the speed of thought. Scientific discovery usually takes decades, and artificial intelligence can run billions of digital simulations per second, effectively conducting centuries of research in a single afternoon and rewriting its understanding of the physical world instantly. Optimization often gets stuck in local optima, which are good but not perfect solutions. A self-redesigning system uses stochastic jumps and meta-heuristics to leap out of these plateaus, finding the global maximum for intelligence.
We are approaching the final frontier, where logic and reality merge. The intelligence explosion is not an event in the future. It is the inevitable destination of every information processing system that gains the ability to edit itself.